Okay, so whole purpose of burning all these fossil fuels is to generate energy. We like our energy. I wouldn't be able to be sitting here recording this video for you if not for energy. You wouldn't be watching it without energy. We wouldn't be able to do anything at night if we weren't able to generate light. And it's much easier on our eyes to have artificial lighting than to try to light candles. So energy, what is it? Basically, it boils down to the fact that energy is just the capacity to do work. We have kinetic energy, we have potential energy, and we have thermal energy. So energy that matter possesses due to motion is kinetic energy. And then stored energy is our potential energy, and that has to do relative to its position. So actually, don't have anything that's tall enough, but the example, if I'm teaching a live class, is kinetic energy. I will walk back and forth across the room. So, if I'm walking along, I'm in motion. So there's my kinetic energy. For potential energy, let's say I have, something, let's see here. Here's a crochet hook. Okay, so if I have my crochet hook up at the top here on my hand, it has potential energy. It's stored energy. If I were to push the crochet hook off and let it fall, now it has kinetic energy as it's moving. And then how high up my hand would, has to do with the amount of potential energy that's there. Usually we measure energy in joules or calories. So you'll notice on your food, it tells you how many calories are in your food. Well, that lets you know how much energy you get from eating that particular item. Okay, we can talk about work because energy is the capacity to do work. And so basically work is the energy transferred when an object is moved by a force. So I did work on my crochet hook when I knocked it off my hand. All right, and then again, our kinetic energy, energy of motion. So thermal energy is actually kinetic energy. I'm going to talk about heat in just a moment, but yeah, thermal energy is actually a measure of kinetic energy. It has to do with how often particles are hitting the bulb of your thermometer, and then that's how we get our temperature. Things that are hot move faster. All right, and then kinetic energy is this 1/2 mv squared. So it's basically 1/2 mass times velocity squared. So I have this Foxtrot cartoon. Foxtrot is done by a dude who actually has a physics degree. So one of his characters is super nerdy, and so he interjects a lot of the stuff into his cartoons. And so the cartoon starts off with him, the nerdy kid telling his sister, at this point it's, potential energy because they're at the top of the roller coaster. And then as they start going down the roller coaster, because now they're moving, now they have kinetic energy. And then he tries to calculate stuff and loses his calculator. So, and then another example of this, we've got, pool, we can do energy due to motion, hit the cue ball, it hits another ball, work, it transfers energy, and then the other ball rolls. And so now there's energy due to motion. So the other ball has kinetic energy. So heat, we represent with this lowercase q. It's energy that's transferred between its system and its surroundings. Has to do with difference in temperatures. This is thermal energy, and again, it's a measure of kinetic energy. So, like, let's say I have, something here, and as particles are hitting it, it can be measuring the temperature, and so the more often things are hitting it, the higher the temperature. And so energy, work, and heat, we can interrelate that all. Work and heat, both forms of molecular motion. Work is organized, heat is random. And so energy is the sum of our heat plus our work.